Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about compound interest. So previously we've talked about simple interest, and simple interest is interest that's only earned on the original principal. It's usually used for short time periods, less than a year. Simple interest is different than compound interest. With compound interest, the interest is earned on the accrued interest as well as the original principal. Let's take a look at an example. With simple interest, if we had $15,000 invested at 6% simple interest for 4 years, okay, it probably wouldn't be if it was 4 years, but we'll just pretend it is, how much money would accumulate? The formula we're going to use for simple interest is this, where this represents the amount in total. This is the principal. This is the interest rate per year, and this is the number of years. So if we plug our values in, our principal is $15,000, our interest rate is 6%, and our time is 4 years. With simple interest, $15,000 would grow to $18,600 in 4 years at 6%. Now let's take a look at what happens if the interest is compounded. So $15,000 is invested at 6% compounded annually. That tells us how often it's compounded for 4 years. So that means at the end of each year, the interest that's earned in that year gets added to the principal, and then for the next year, interest is earned on that total. So let's take a look at what's happening at the end of each of the years. So at the end of year 1, if we take our principal of $15,000 and times in our formula 1 plus the rate of 0.06 times the time of 1 year, so that'll just stay 0.06. When I add those, I get 1.06, and when I multiply that to 15,000, I now have 15,900. In year 2, I'm going to earn interest on this amount, not just the 15,000. So let's continue. So at the end of year 2, if we take our investment of 15,900 and multiply by 1 plus 0.06, which is 1.06, we get 16,854. Again, next year, we're going to earn interest on this whole amount, not just the 15,000. So let's continue. At the end of year 3, this is what we're earning interest on. So we take that and multiply by 1 plus 0.06, which is $17,865.24. And in the last year, in year 4, we're going to earn interest on this whole amount. So we take that and multiply by 1 plus 0.06 or 1.06, and we get $18,937.15. So at the end of 4 years, this is what our investment is worth compared to when we were earning simple interest. So when you're earning interest on the interest, your investment grows faster. Now, when we're working with compound interest, we don't want to have to go through these steps, so let's just shorten this a little bit. Another way we could have calculated that total at the end of 4 years is by taking the principal of 15,000. After the first year, we multiplied by 1.06. After the second year, we multiplied by 1.06, and so on. So in other words, we multiplied by 1.06 4 times, and the way we can express that is with an exponent. So if we took 15,000 and multiplied by 1.06 to the 4th power, we should get what we obtained doing it step by step. On your calculator, you'll have a power function, and if your calculator is following order of operations, then you should be able to just type this in as 15,000 times 1.06, raise it to the 4th power. It will just do the exponents first, and then equals, it will then do the multiplication. And you should get $18,937.15. The example that we did, we had the interest being compounded annually, but there's different time periods that compound interest can happen. It can be done semi-annually, quarterly, monthly, weekly, daily, and so on. So let's take a look at what the formula looks like with different compounding periods and do some examples. Let's start by taking a look at the compound interest formula. And don't be intimidated. Hopefully it'll make sense as we go through examples, but it does look a little bit intimidating to start with. A, which represents our future value, or what our investment will be worth at the end of the whatever term, that will be equal to P, which is the principal or present value, times 1 plus R over N. R represents the annual interest rate, and n represents the number of times per year that the money is compounded. So in our last example, it was compounded annually, so n would be a 1. Then we take this expression and raise it to the power of n times t, where t is the time in years. One way that you can think of it to hopefully make it easier is that this value here represents the interest rate per compound period. And this exponent, n times t, will represent the number of compound periods. Let's take a look at the different time frames for compound interest. So we already looked at 6% compounded annually. You might see CA abbreviation. So in that case, if it's compounded once a year, the n is 1. And R over n will be the annual rate, which is 0.06, divided by 1, which would be 0.06. On the other hand, if it was 6% compounded semi-annually, that's twice a year, so where n is 2, and R over n would be 6% divided by 2, which is 0.03. So we'd have 0.03 as our interest rate per compound period in this example. If we had 6% compounded quarterly, that means 4 times a year, so n will be 4. And R over n will be 0.06 divided by 4, which is equal to 0.015. If we have 6% compounded monthly, that means we have 12 compound periods in a year. And R over n would be 0.06 divided by 12, which is 0.005. If we had 6% compounded weekly, we would have n equal to 52, and then R over n would be 0.06 divided by 52, and we would leave it in fraction form when we did calculations because this doesn't work out to a nice even decimal. If we had 6% compounded daily, then we would use 365 for n, and R over n would be 0.06 over 365. Again, we'd leave it in that form because it doesn't work out to an even decimal. Now let's do some examples. Our first example says $15,000 is invested at 6% compounded monthly for 4 years. What is the future value? So we're finding this, we need to know all of these values. So principal is $15,000. Interest rate, annual interest rate is 0.06. It's compounded monthly, so n is 12. And number of years, t is 4. So let's plug these values in. A is equal to principal of 15,000 times 1 plus annual interest rate is 0.06 divided by n, which is 12, raised to the power of n times t, so 12 times 4. Let's simplify everything before we bring in our calculator. Because this works out to a nice even decimal, I'm going to write that down. If it didn't, I would keep it in fraction form and put that into my calculator. 12 times 4 is 48. If your calculator is following order of operations, you can simply type it in as you see it. 15,000 times bracket 1 plus 0.005, or the fraction, whatever the case is, end of bracket. Then use your y to the x key, raise it to the power of 48, and then press equals. It will do what's in the brackets first, then it will do exponents, and then it will do multiplication. And your answer should be $19,057.34. In our second example, we have $5,000 invested at 8% compounded weekly for 10 years. What is the future value? So our principal is $5,000. The annual interest rate is 8%. The number of compound periods in a year, if it's compounded weekly, will be 52. And the number of years is 10. Now we're going to plug these values into our formula. So 5,000 times 1 plus 0.08 divided by 52 raised to the power of 52 times 10. You can put this into your calculator at this point, but you might have some problems if you don't handle the 52 times 10 correctly. So I'm just going to multiply that first, and I'm going to plug this into my calculator. 5,000 times bracket 1 plus 0.08 divided by 52, end of bracket, raised to the power of 520. You should get $11,120.87. Next example says that $20,000 is invested at 5% compounded quarterly for 3 years. What's the future value? So principal is $20,000, annual interest rate is 0.05. If it's compounded quarterly, that means that there are 4 compound periods in a year, and the number of years is 3. Plug those values into our formula. Here's what you get. And you might want to multiply 4 times 3 first before you plug this into your calculator. So in 3 years' time, your investment's going to be equivalent to $23,215.09. So far, we've been talking about investing money, but we can use compound interest with loans as well. So let's do an example of a loan that has compound interest, and let's take a look at what happens if we're making payments during the duration of that loan. So in this example, it says a loan of $8,000 at 9% compounded monthly requires 3 payments of $2,000 at 6 months, 12 months, and 18 months after the date of the loan, and then a final payment of the full balance after 2 years. What's the final payment? So if we were to take a look at a timeline, the date of the loan, we're borrowing $8,000. 6 months later, we're paying $2,000 back, then another $2,000 at 12 months, another $2,000 at 18 months, and then we have to make one final payment. So we have to do these in a series of steps because the balance of the loan does not stay $8,000 for the whole 2 years. So what we're going to need to do is calculate how much is owed at 6 months, and then we'll subtract our payment, and then use that value to find out how much is owed at 12 months, subtract the payment, and so on. So it's a little bit tedious, but let's go through it step by step. So at the end of 6 months, let's find the future value of this $8,000 loan if there's 9% annual interest and it's compounded monthly. So if we put it into our formula, principal or present value will be $8,000 times 1 plus our annual interest rate of 0.09 divided by the number of compound periods per year. If it's monthly, then that will be 12. And we're going to raise that to the power of 6 months. We could think of it as half of a year times 12 payments, so half times 12 is 6, or just realize that because it's compounded monthly, in 6 months there will be 6 compound periods. So this is going to be the future value, and then we're going to subtract $2,000 for the payment that's made. So at 6 months after we make that payment, the loan is now going to be $6,366.82. Now let's find the future value of this amount at 12 months and then subtract our $2,000 payment. So the future value of this amount will be calculated by taking that amount and multiplying by 1 plus 0.09 over 12 again. From 6 months to 12 months is 6 months, and that's compounded monthly, so there's 6 compound periods. That will be the future value, and then we're going to subtract our $2,000 payment to find out how much is still going to be owing, and this will be what's owing after 12 months. $4,658.75. We're going to do the same thing to find out the future value of that present value at 18 months, and then take away our $2,000 payment. So now to find the value of this at 18 months, we use our formula. So we take that value, multiply by 1 plus 0.09 divided by 12. Again, it's 6 months, so 6 compound periods. And we're making a $2,000 payment, so we subtract that. Once that payment is made, this is what we still owe on the loan. We're not paying it off at this point, we're paying it off in another 6 months. So now we just need to find the future value of this amount at 2 years. Again, using our formula, we take this value and we want to find what it's worth 6 months later. So we multiply by 1 plus 0.09 divided by 12 to the power of another 6 months or another 6 compound periods. And that will equal $3,004.07. So this is what the final payment will be made at this time. And if you're wanting to find out how much you actually paid in total for that loan of $8,000, you can add up all of your payments. and you'll see that the total is $9,004.07. So from that, you can calculate how much interest was paid on that particular loan. Now we know how to find future value with a compound interest loan or investment. In the next video, we're going to talk about how we find present value.